Hi there, folks. Today we're looking at polynomials, linear factors, and zeros. And the idea behind this lesson is just to kind of draw a quick sketch of the graph to get an idea of what it should look like. The graphs are not going to be overly detailed. They're not going to be overly accurate. We just want to get a general shape. When we go to do the accurate types of these graphs, we're going to use graphing calculators. We're going to use computers to kind of come up with all those really specific points that we need, all right? But when we first plug these into a graphing calculator or a computer, the graph is going to look like gibberish, and we need to know how to kind of interpret that, all right? We're only going to see a piece of the graph. We're not going to be able to see the whole thing when we first put it in there. And so it's helpful to understand, okay, this is kind of what the graph should look like, and that kind of tells me how I should zoom in or out and adjust the graph that I'm looking at in order to find those pieces that I need, okay? So for graphing a polynomial in factored form, all we're going to do is find the X intercepts and then use the end behavior to determine the path of the function, okay? And you'll see what I mean in a moment. Once we have the X intercepts graphed, there's really only maybe two options for the path of the function. And as soon as I know the end behavior, I'll know which one it has to be, all right? For example, if I look at something like this guy, I'm just going to find the X intercepts. And to find the X intercepts of any function, I plug a 0 in right here for y. So if I set this equal to 0, well, I just set each factor equal to 0. So now I do x minus 1 equals 0. I do x minus 3 equals 0. And I do x plus 2 equals 0. Okay? So to find the X intercepts, I plug a 0 in for y. I solve for x. So now I set each of these equal to 0, and I solve for x. So here I would add the 1. Here I would add the 3 and get x equals 3. And here I would subtract the 2 from each side and get x equals a negative 2. And so each of these represents an ordered pair. This is the ordered pair 1, 0, 3, 0, and negative 2, 0. Okay? So let me plot these over here. And so if I plot these things, sorry, this one is not quite even with the rest. There we go. And so I plot these couple points, and negative 2 is over here, 1 is right here, and 3 is right here. Okay, and make sure these are labeled in some way. If you don't draw the little dash marks, just write the ordered pair next to this guy. Just say, hey, that's negative 2, 0, just so we know where it is. Okay, hey, this is 1, 0. Got a little ahead of myself there. Okay, so just label these in some way so we know which thing is which. Okay. But now the idea behind this is think about the different ways that I could draw this function, all right? Like this end could be going down, and if the end of the function is going down on this side, it means I would have to go through this point, then come back down through this point, and then come back up through this point, okay? But the other option is, what if the function goes up on the left-hand side, right? What if the function starts up here? Well, then the function would have to go through this point, then through this point, and then through this point. Okay? And so when I look at this, these are the two options. These are the two paths based on those x-intercepts that this function could follow. The end behavior will tell me which one it is. And so once again, the end behavior for this one, I just multiply the first terms. So as I multiply out these first terms, and there's a 1 out front, it gives me a 1x to the third. Okay? So my starting value is going to be a 1x to the third. And yeah, there's a bunch of other values that I don't care about. But now when I look at this thing, it's an odd exponent. All right, so it's an odd degree, and it's a positive coefficient, which means this is going to follow like a positive slope. So the end behavior is going to be down, up. On the left side, it's going to be down, and on the right side, it's going to be up. So look at the two paths that I have. Look at these two options. This one, down, up. So it's got to be the one in green. So I can erase the purple. And that's it. Here's a quick sketch of this graph. This is kind of what it looks like. And the idea here is I know now that there is a relative maximum somewhere in between those two x values. I know that there's a relative minimum, okay? And when we start to go into the details and use the calculator to get these things, we're going to go find those things. But we know where to look now because I understand the graph of this thing, the shape of this thing has to be something like what I have drawn here, okay? If I look at this next one, same kind of thing. I want to find the X intercept, so I'm going to set this equal to 0. So I set each of these factors equal to 0. And and I solve each. This one I get x equals a 0. This one's a -1. Here I get a +4. Here I subtract 4 and get a -4. Okay? And again, each of these is an ordered pair. And now from here, I'm going to plot these. Let's see. I can space those out just a little bit more. And so I plot these points. Here we go. See, I've got it at -4. I've got it -1, 0, and +4. Okay, so those are my X intercepts. Well, now I just need to figure out which path this thing is going to follow. All right, and instead of drawing the two paths, I could draw them again. It could start down here, and I'd have to go like this and through that point, so I have to hit each of these. So that was terrible looking. All right, or it could go down like this, and then up, and then down. Okay, and so I could have one of those two paths. Well, let's find the end behavior, okay? And I'd like to find the end behavior. I don't want to draw these and then erase one. So let's find the end behavior. Once again, I only want the first value, so I multiply all the first values here. And if I multiply all of those, that gives me a -1, x to the 4th. And yeah, if I multiplied all that out, there'd be a bunch of other terms, but I only want the first one, right? And so since I only want the first one, there it is. It's an even exponent this time, so it's an even degree with a negative out front. So think back to your quadratics, okay? If you had a quadratic with a negative coefficient, it would open down, so both ends would open down. And it's the same for all other even degree polynomials, okay? And so this one is going to be down, down. And so what we do, we know on the left side it should be down, so I just draw a little piece that's down, and now I start to sketch this thing. Now let me use a different color. I'll use purple this time, since it got erased last time. So now it has to go through this point, has to come back down through the next X intercept, through the next X intercept, and then through this last X intercept, okay? And again, in terms of accuracy, this isn't super accurate. It might do something more like this. Maybe over here it goes up. Here it doesn't go down much, but maybe over here it goes up a lot. Okay, and so again, I don't know exactly what this thing looks like, but I have an idea in terms of the path. I know that somewhere in between here, there's a relative maximum. I don't know where it is. I know that somewhere in between here, there's a relative maximum. I know somewhere here, there's a relative minimum. Okay, this sets me up to be able to find those values when I plug this into a calculator or when I do this on a computer. Okay, I just want a quick sketch, a quick idea of what this thing's supposed to look like, so I know where to look when the time comes. Okay? And once again, double check that end behavior. It's down on each end. Okay? The only other thing we need to talk about here when we're trying to draw this quick sketch is multiplicity. All right? Multiplicity is when a 0 occurs multiple times. So when I get the same X intercept more than once. All right? And here's how that affects the function. All right? When you look at the previous examples, all of them had a multiplicity of 1. All right, every X intercept only occurred once. Okay, so that's the multiplicities, how many times it occurs. All of them have been 1 so far. All right, if I have a multiplicity that's even, if I get the same X intercept twice, or 4 times, or 6 times, or 8 times, instead of it crossing the x-axis, it's only going to touch the x-axis at that point. Okay. And so we'll have a relative minimum or relative maximum at that point, all right? It's going to kind of glance off the thing. If the multiplicity is odd, like the ones we've been dealing with, if that solution happens once or 3 times or 5 times, all right, then it will actually cross over the x-axis like we've been doing, all right? And so it adds this slight element to kind of the shape that this thing is going to take on, all right? And so if I look at something like this guy, once again, and we can identify multiplicity just based on some exponents here, like right here. We see this x squared. That means I have 2 of those x's. It means I'm going to do x equals 0 twice if I split that x squared up into an x times x. Okay? And then I do the x plus 2 equals 0. And then I do the x minus 4 equals 0. Okay? And so that exponent causes me to have that same x-intercept twice. okay? And so as I kind of look at this, I solve each of these. So I'm just finding my x-intercept. These are already solved, but I'll write them down. Okay? But I got that same answer twice. And let me just write it once as one ordered pair, because I'm not going to have this, I'm not going to have that ordered pair twice. There's only one of that ordered pair. But now the idea here is the multiplicity. How many times did I get that answer? And so if I identify the multiplicity on this, well, this answer occurred twice, this answer occurred once, and this answer occurred once, which means when I get to this first value, because the multiplicity is even, I'm only going to touch the x-axis, okay? But when I get to this one, because the multiplicity is 1, it's odd, I'm going to cross over the x-axis. Same thing with this one. The multiplicity is odd, I'm going to cross over. And again, that even or odd has absolutely nothing to do with the actual value. It has nothing to do with this 4, okay? It only deals with how many times I got that value, which is this guy. That's the multiplicity is 1, okay? And so I approach this the same way I did before. Ready? I plot these points. See, I've got 0, 0, I've got -2, and I've got 4. Oh, should have used a different color there so we can see them. And now I look at the end behavior. Once again, I just look at all the first terms, x squared times x times x. So that's going to be the first term is going to be a 1x to the 4th. And again, we're ignoring the other terms, but that makes the end behavior as up, up, even degree that has a positive exponent. And so now right away, ready? I know at this end, it's going to be going up. And so as I go to this first point, I'm going to cross through the x-axis because the multiplicity was odd. That was the -2. And so as I approach the next value, as I approach the 0, 0, I have to remember that the multiplicity is even. I only want to touch there, which looks like this. So it's like a relative maximum right at that point. It just touches. And now as I approach the next point, I'm going to cross through the x-axis because, once again, the multiplicity was odd. That's that slight effect that this thing has. Okay? So when we have an even multiplicity, that's what changes things. That makes us kind of do a relative minimum or relative maximum at that point, where we just touch the axis. And notice, look at my end behavior. It works out up, up. Okay? So now, when I go to do the detailed graph, I know that there's a relative minimum somewhere in here. And I know there's another relative minimum somewhere in here. The relative maximum, I already have. Okay? If I look at this one, same kind of thing. If I set this equal to 0 and find the x intercepts, I've got x minus 2 equals 0, and I've got x plus 1 equals 0. And that's it. I only have 2 things I'm going to find. But keep in mind, right here, the x minus 2 is squared, so maybe I should write it out. Ready? That means I have 2 of these guys that I have to set equal to 0. And the x plus 1, well, I have 3 of those, so I have to technically do that 3 times. And here's the thing, I don't need to actually solve that 3 times. I just need to understand that that exponent means I have it 3 times. So here I solve this guy, that's x equals 2. All right? And yeah, I would get that answer a second time. Here I'd solve this guy and get x equals a -1. And yeah, I would get that answer 3 times. Okay? And so as I kind of look at this, let me write the ordered pairs. When I talk about, well, how many times would I have gotten that answer? That's multiplicity. That's what we're trying to refer to here. So the multiplicity this time, I would have gotten this answer twice. And this answer, I would have that 3 times. So now the multiplicity for the first answer is even, which means I'm only going to touch the axis. The next one has a multiplicity that's odd, so I'm going to cross over the x-axis. I'm going to pass through it. Okay? And so that's the idea here. And I don't need to write that out a bunch of times. I just have to look at the exponent. Okay? X minus 2 equals 0. I get x equals 2. And hey, that had an exponent of 2, so I'm going to get that answer twice. X plus 1 equals 0. I get x equals -1. Had an exponent of 3, I'm going to get that answer 3 times. Okay? And now looking at the end behavior. Again, just looking at those first values, this is going to be an x squared. This is going to be an x to the 3rd, and then times this -1. So x squared times x to the 3rd times -1 is a -1 x to the 5th. Okay? So now I have an odd degree with a negative leading coefficient, which means this thing is going to be up, down. It's going to follow the same pattern as something with a negative slope. And now let's plot these. So here I've got 2, 0. I've got -1. I know that the left-hand side, this thing is supposed to open up. So that's this way. And so as I approach the -1, I already know I'm supposed to cross the axis here. And then as I approach the 2, I'm only supposed to touch at that point. So I get a graph that looks like this. And yeah, my graph's a little wonky, and sometimes you do have these kind of inflection points down in here where it kind of changes direction in terms of the curve. That happens sometimes, okay? And we'll see that as we start to explore the graphs, okay? But now I have my end behavior of up, down, and I just have a quick sketch of these things. So now I know where to look when it's time to graph this thing. I know where to look for this relative minimum, okay? Once again, I already have the relative maximum here, okay? So again, when we're looking at these things, we just want to draw a quick sketch. We're looking for the X intercepts. We're looking for the end behavior, and we have to worry about multiplicity, okay? If I have an X intercept more than once, all right, if it occurs an odd number of times, I go through the axis. If it occurs an even number of times, I only touch the axis, okay?